The dark side or other side of the moon are referred to in many movies. However, we've never actually seen the other side of the moon. So why can't we see both sides of the moon? In school, we learn that planets and moons have their own rotation, as well as rotating around another object. For example, I'm going to draw a circle, and this will be any planet. Then my finger is going to be the moon, and it will go around the planet. As you can see, the planet sees all sides of my finger, top, bottom, right, and left. So in theory, we should be able to see both sides of the moon. However, our moon has a phenomenon called tidal locking, or synchronous rotation, which is defined as an object rotates on its own axis at the same time it takes to orbit another object. The moon takes about 27 days to do a full rotation by itself, so a 360. Now to do a full rotation around Earth, it takes about 27 days. The times match up, which create an orbit like this. Has the moon always been like this? Well, no. And in order to explain this more, we need to go back to the beginning. So there are many theories out there on how the moon was actually formed. However, we do know a few things. We know that the moon has rock samples from Earth, as well as knowing that a high energy impact happened. So knowing these things, we can put together theories like a huge impact of an asteroid hit Earth, which then shot debris out into space, causing the debris to be rotating around Earth, almost like Saturn's rings. So finally, the debris kind of came together or formed together to create the moon. Now, because of these stages, the moon was most likely spinning really quickly. So now the moon is rotating around Earth. And the Earth and the moon kind of figured out that when they're aligned, they have something called tidal force, which is defined as a difference in the strength of gravity between 2 points. So this gives the moon a football-like shape and the Earth have high and low tides. So in order to have this force, the Earth would tug at the moon because the moon would keep spinning, and when it spun, it would be out of alignment, so the Earth would tug at it. So if the moon went slower or faster, the Earth would tug at it. For example, pretend you're having a tug of war with someone. They're tugging and tugging, and you're tugging and tugging. In the end, you're both going to become tired and start getting slower. So gravity tugged so much that the moon became locked. The culprit of why we can't see both sides of the moon is called tidal locking, which means the moon's rotational speed and orbital speed synchronize with each other. Who knew a game of tug of war could cause such drastic changes?